This will be the 7th grade Unit 2 test review that we should be having on Wednesday, or this coming Wednesday. So I'm going to go ahead and get going on this. I will not be answering I won't answer the questions all the way on this thing, but I'm going to, at the very least, lead you to them. So number 1 says, Allie read 25 pages of a new book the first day she bought it. After the first day, she read 5 pages a day. If the book was 350 pages, write an equation that can be used to determine how many days it will take Alyssa to finish her book. Apparently, we changed people halfway through this problem. That's probably supposed to be Allie or Alyssa. Actually, hang on. A-L-L-I-E, because I can't spell. A-L-L-I-E. See, that says Allie. Okie doke. So now here's what we're going to start with. We know that this person that the book is a total of 350 pages. So that is the amount that we are going to start with for our equation. It has to be 350 is going to equal what is happening in the rest of the situation. Allie read that 25 pages on the very first day. So that only happens one time. You can't read more, she read the 25 pages in one day. She's not necessarily going to do that much every single day. And this says after the first day, she read 5 pages a day. That's I know it says a day, but it's per day or every day or whatever else you want to go with. So we know that X or D or whatever letter you want to use for days, we are going to use that for days. So 5X or 5 pages per day. So you're going to be looking at 5X. And so now we're trying to get we need our total to equal that 350. So we're going to have our 25 pages out of the book. We are also going to have our 5 pages per day. Hopefully you were listening to the video so you can finish that part up. So on number 2, solve and graph the number line solution for the equation. So first we've got to come up with the answer to this equation. I'll have to make a little bit of a number line along with it too. So on this one, we're going to draw our line down the middle and start solving from there. This is a 2-step equation. My goal is to get everything away from the x. Start with addition subtraction first. So I have to subtract 10 here. I also have to subtract 10 over here. These two will cancel out and I'm done with it. On the left side, that 6x, I haven't touched it, so I have to keep that. This is why I beg you guys to keep things lined up. On the right side, I have negative 8 minus 10, so I'm going even more negative. That is going to be negative 18. Now I'm left with multiplication on the left and just a digit on the right. So I'm going to get everything away from the x by dividing. I have to divide by whatever is with that variable. So I'm going to divide both sides by 6. I'm left with x on the left. On the right, negative 18 divided by 6 is going to be negative 3. So it wants us to graph this on a number line. This is kind of a silly one to do. Actually, it's very much like this on the test because it's not asking us to use a greater than, equal to, or whatever else. Since our answer is negative 3, I'm just going to draw a quick number line. It really doesn't matter. I know that I need to have negative 3 on there, so I'm just going to put it in the middle. And look, there's my answer graphed. But I need to have a little bit more information than that, so I'm going to kind of count back up. There's negative 1, 2. I can have 0 all the way there. Have negative 4. And I know I said I wasn't going to do these all the way for you, but look, I just did this whole thing for you. But I've got my dot on negative 3. I'm going to change colors just so that's a little more obvious. My dot needs to be on negative 3 because that was my answer. It wasn't negative 4, it wasn't negative 2. It's not all the things on the left. It's not all the things on the right. It's just an equal sign. Now for number 3, this one is just a inequality, but we are going to solve it just as if it were a 2-step. So draw my line down the middle. I need to get everything away from x, so what I'm going to do is I'm going to add 2. I have to do plus 2 over here, plus 2 over here. These will cancel out, and I'm done with it. On the left side, I'm left with my 12x, so I'm going to bring that down. On the right side, I'm left with, 1 plus 2 is 3, and I've got to keep my sign, that greater than or equal to symbol. I've got to get everything away from the x, so I'm going to divide by 12. What I need to make really, really clear to you guys is I'm dividing by a positive number. I don't have to do anything with that symbol. It's going to stay exactly like it is because I'm dividing by a positive. So this side divided by 12 and this side divided by 12. These two will cancel each other out. And this is going to be x is greater than or equal to, well, I can't see how many times 12 goes into 3 unless I want to get a crazy decimal number. I can call it 3/12. Or I can simplify it. On your paper, I expect you guys to simplify it because you guys know how to. So don't tell me your answer is 3/12 when I ask you. You should be able to simplify that. And I believe on your actual test, you need to be able to plug your answer choices back in. You can either go through, I think what you have is your answer choices all have multiple inequalities that you can solve, or you can just try plugging in answers for x. If you need help with doing that, actually, I'm going to go ahead and do that real quick. We're going to take that 3/12 and I'm going to plug it in. I have my answer of 12, I'm sorry, not my answer, my original problem. 12x minus 2 is greater than 1. But what I'm going to do is I'm going to take that 3/12 and I'm going to plug it in right here. This is multiplication because those two numbers are right next to each other. So this is going to be a couple different things. Hopefully you guys know how to multiply integers and fractions. It shouldn't be too bad, but I'm going to show you this part real quick. You make the top, that 12 has to be 12 over 1, and it's going to be times the 3/12, and you multiply straight across. 12 times 3 is 36. 12 times 1 is 12. And 36 divided by 12 is just 3. So I need to make it really clear that what has happened here, because I know this is kind of difficult to read, I just took these and multiplied them, and now I have 3. So I'm going to go ahead and rewrite this because that got real sloppy. So I now have, on the left side, I have 3 minus 2 is greater than 1. So 3 minus 2 is 1. And I have my greater than symbol. And I have 1 is greater than 1. This is not a true statement. So we probably messed up whenever we copied it. My guess is that right there is supposed to be a greater than or equal to symbol. So just to fix this problem a little bit, I'm going to make this an or equal to, just so we don't have to completely rewrite the problem. Or equal to, and finally, for this part, or equal to, because 1 is greater than or equal to 1. So that makes it a true statement. We just had to change that up just a little bit. All right, for number 4, it says solve and graph on a number line the solution for this equation. So we're going to have to solve this thing, and then we're going to have to figure out how to draw out a number line for it. So I'm going to draw my line down the middle, because that's what we do. I've got to move that 8 away from that x, because I have to start with addition or subtraction. That 8, I know it's not written there, but that 8 is positive. So I'm going to subtract 8 on both sides. These two will cancel out. On the left side, I'm left with negative 2x is going to be greater than, I'm going to change colors just so it's there so you can see it better. And then 18 minus 8 is just going to be 10. This is the tricky part. This is what will get you on the test on Wednesday. That is a negative 2x. To undo it, I have to divide both sides by negative 2. When I divide by negative 2, my sign has to change the opposite way. So I'm going to rewrite this. These two will cancel. I have x is greater than 10 divided by negative 2 is going to be negative 5. But now we have to graph this thing. So I'm going to draw out my number line real quick. I'm just going to put negative 5 in the middle. So there's negative 5. I've got my negative 4, negative 3, negative 2. We'll do negative 6, negative 7. All right, now I'm going to go back. We have a greater than symbol. So my circle is going to be open on negative 5. And x is bigger than that thing. So you need numbers that are bigger than negative 5. You guys should be pretty comfortable with that at this point, so I'm going to have you guys finish graphing that one on your own. All right, number 5. Carnival charges $6 to park plus 50 cents per ride. I'm going to go ahead and mark this as I see it. That $6 to park is going to happen one time. When you go to the carnival, you only have to park one time unless you just decide to leave and come back. Hopefully you got a parking pass. Plus, so that says plus for us. That kind of hands it to us. 50 cents per ticket. So you're going to have to pay for each one of those tickets. So how many carnival rides can a person ride at the carnival if they spend a total of $26 at the carnival? It says write an equation for this problem. We are not even having to solve it. It's just write the equation. Okay. And it says 26 is our total. So I'm going to go ahead and write that part out because that's pretty easy. So we have, actually I should have changed colors on that just so it makes more sense. So I can write things to match. So we're going to have 26 for our total. The $6 to park, so that's going to most likely go right there. And it says plus 50 cents per ride? I want you guys to figure that out, because per means that we're going to have an X with it. X is going to represent how many tickets we have purchased. All right, number 6, because I got to speed up a little bit because this is taking way too long. 10 minutes on 6 problems. A fence is in the shape of an isosceles triangle. The fence is at least 14 yards long. The length of the unequal side of the triangle is 4 yards. What is the length of each equal side? Write an inequality for this problem. Okay, so isosceles triangles, for whoever does not remember, look kind of like this, where these two sides are the same and that side right there is usually different. Kind of looks like a little mean guy. Okay. The fence is at least 14 yards long. So here's what I'm going to do. I'm going to go and write out my 14 over here. And my fence, if it's at least, that means the fence can be bigger. So we're going to have the fence over there on the right side. So everything over here on the right should be bigger when I get done. It says the length of the unequal side of the triangle is 4 yards. So this right here, they're saying this part right here is 4 yards long. Well, I've got two sides that I don't know the length of, and I know the length of one side. So I need to have my 4 right here. It's just going to happen because I need that whole thing to be, so I'm getting a total. So we're going to add, the whole thing's got to be bigger than 14. So now I've got my 2 other sides. Well, my 2 other sides, I don't know the length of. They could be just about anything as long as the whole fence is bigger than 14 when we're done. We have 2 sides that we don't know. And because we don't know them, we're going to call it 2x. I kind of handed you this one. Okay, on to the back side. I'm going to have you guys fill some of these out for yourself. Model below represents an equation. What is the value of x that makes this equation true? I need you guys to be aware that because these two things line completely up, that thing is worth that thing right there. Which means that if this is 9.4 down here, let me use the highlighter, if that's 9.4 there, this part right here is also worth 9.4. What I want you guys to do is set up the equation, and I want you to solve this because you are figuring out what each part is. So here's what I'm going to do. I'm going to go ahead and write it out because I need you guys to know that 21 equals those 2 x's plus that 9.4 together. That's just the equation for it. You guys still need to solve for what these x's are worth. We got 2 of those x's. Oops, I hate it when I use the wrong thing. 2 of those x's are going to be worth 2 of these x's right here. You can probably see it and kind of figure it out in your head, but I still want you guys to solve that one. If you don't solve it, it's wrong. Number 8, just another solving one. Gonna go right here, draw my line down the middle. Got to get everything away from the x. That 2 right there is positive. You've got to remember that. So I've got to subtract 2 on both sides. These 2 will cancel. On the left side, I'm left with negative 3x. On the right side, I have 8 minus 2, which is just going to be 6. Fortunately, there aren't any inequalities on this one, so it is just equal. That final step, that is multiplication right there, so you're going to have to divide both sides by negative 3. Again, you guys should be pretty comfortable with 2 steps. If you are not at this point, you need to ask. I want you to finish that one up on your own. Number 9. Mrs. Melvin has a budget of $715 to spend on books. She orders from a company that charges $8 per book plus a $75 shipping fee per order. The librarian uses an inequality. There's the inequality for us, where B represents the number of books ordered, to determine if she has enough money to place an order for a specific number of books. Mrs. Melvin already had a list of 50 books she wanted to order and planned to add more books to her final order. Will Mrs. Melvin have enough money to add 45 more books to her final order? Explain why or why not. So this problem sucks. We're going to jump to the equation because they've already got part of it written out for us. So here's the equation right here. In fact, I'm probably going to kind of write that out for my own use. They figured out a lot of this for us. They took the 715 because that's our total. They already plugged it in there for us. They took the $8 per book, and they already have that part of our equation in there for us. But now we are just trying to figure out how many books she can order. So she's already ordered 50 books, right? And she's wanting to add another 45 on there. So if we take that 50 and that 45, if we put these two together, we have a total of 95 books that she wants to order. So what we're going to do is we are going to take that 95 and we're going to plug it in here for B, and we need to see if this is a true statement. So the first thing I'm going to do is I'm going to take that equation. I'm going to rewrite it real quick. So I've got 8B plus 75, and I already forgot the rest, less than or equal to 715. If Miss Melvin's going to order these 95 books, again, I know I just said it, but I want to make it really clear that I'm plugging that in for B because I need to see if this is a true statement. So now what I'm going to do is I'm going to take my 8 and I'm going to take my books. We've got 95 books that we were talking about. We have to add on 75 to that, and we want to know if it's less than or equal to 715. What you're going to do is you multiply the 8 and the 95, you add on 75, and you just see if that is a true statement. You guys got to finish this one up on your own. Number 10. All right, number 10 is just another two-step equation. I know that 1/2 makes everything look scary, so we will talk about that when we get there. Actually, I lied. We're going to go ahead and talk about it right now. 1/2 times x is the same thing as x over 2. Those two are the exact same thing, okay? So I'm going to go ahead and rewrite this. We've got x over 2 plus 17 equals, was that 13 right there? Yep. I'm going to draw my line down the middle. I've got to get rid of that 17, so I'm going to subtract 17 on both sides. These two cancel out, and I'm done with it. On the left side, we are left with that x over 2. And 13 minus 17 is going to be negative 4. Our final step, you guys know that that is division right there. To undo division, you have to multiply. Multiply both sides by 2 and find out what x is. So I'm going to let you guys figure that part out for yourselves. Down to the last two. Sarah discovered an error in her checkbook register and recalculated her balance. She determined that she was overdrawn. Her balance in her checking account was negative $838.57. Sarah saved 2 of her paychecks, each in the amount of $398.20 for a special occasion. If Sarah deposited both checks in her checking account, what would be Sarah's new balance? Again, I'm not going to work this out for you all the way, mostly because this is an older problem. So we're first dealing with a negative $838.57. What is extremely important on this is she has, where is it? She saved 2 of those paychecks. She's got this thing times 2. So you need to find out how much money she's actually got to deposit now. Once you've got that in there, you've got to add it to whatever this is, to that negative $838. You're going to add that part, and you're going to find the remaining balance. If you get stuck, let me know. So I'm going to say it one last time. Multiply that $398.20 times 2, because you have 2 of those paychecks. Insert it here and subtract. Check it on a calculator later if you need to. Final one. Again, this is another one that you guys have seen before because we got to jump back to these at some point or another. Number 12, to complete a planter box project, Mr. Boykin will purchase cedar boards that are 2 inches wide and 120 inches long. He will need to cut down the lengths of the boards into pieces that are 1 1/4 inches long. And I know that looks really weird. That's supposed to be, I wish it didn't look like that, but it does. So we'll clarify again come test time. But 1 1/4, that is 1 1, nope, that's a terrible color to do that in. It's going to be 1 1/4, okay? I know that's really difficult to see on that, but I want to make it really clear. Okay, how many pieces can Mr. Boykin cut from each 120-inch long board so he can determine how many he will need to purchase? We've talked about this one before. If the board is 120 inches long, and he's going to take that, and he's going to cut it up into the other pieces, he is dividing that up into smaller pieces. Fortunately, on this one, we simplified it just a little bit. He's doing it's already 120 inches. We don't have to change anything to feet. There's nothing weird to do. I know that conversion threw a lot of people off. We're cutting it up into the 1 1/4 inch pieces. So we're going to take that 120 and we're going to divide by 1 1/4. There are a couple of things that you're going to have to do on this. For starters, remember that this is the only time that you ever do keep, change, flip. First, we're going to set up our little Texas method. We're going to change this thing to an improper fraction. So we're going to Texas it. That's where it's plus and times there. 4 times 1 gives us 4. Plus 1 more will give us 5. So we have 5 over 4. Now I'm going to set up this final part for you guys, and then you'll be finishing it up on your own. So we have 120. We're going to make that over 1 divided by 5/4. But that's much more difficult to do unless we do our little keep change flip trick, which personally, not a big fan. So we've got 120. We change the sign and we flip the fraction. Now we can multiply straight across and simplify when we're finished. That is what you guys are going to be looking for on that one, okay? If you got any questions, please let me know.